Hello, welcome to the playlist of videos on essential statistics for data science. I am Hemakumar Kasala, and in this introductory video, I wish to cover the following basic topics to begin with. Statistics and data. Why learn statistics? The primary driver to learn statistics, that is the variability. What is descriptive and inferential statistics? Process of data analysis in statistics. Univariate and multivariate data for statistical analysis. Types of data: categorical, numerical, continuous, and discrete data. And a brief introduction to basic visualization of data. Let's get into the video. Availability of huge amounts of data as such gives no advantage unless one can make sense out of that data. Statistics is a discipline that provides the means to extract the sense out of raw data. Uncertainty and variations are inherent of data. Statistics helps make intelligent judgments and informed decisions in the presence of such uncertainty and variations. What purpose does statistics serve? In order to understand this, let's take a look into some surveys conducted. Survey reports suggest 42% of men and 32% of women shop online at work. 40% of travelers check official email while on occasion. 33% take cell phones to stay connected with work, and 25% carry laptops on vacations. Children bottle fed for longer than 1 year are found 3 times more likely to be iron deficient. Are these reports correct? To be precise, are they statistically correct? The first purpose, or step 1 in a statistical study, is to gain more insight into the study reports. More insight means more information. That includes being able to extract more information from the tables, charts, and graphs from the reports, understand the arguments involving the various numbers presented in the reports, and learn how the data are gathered, summarized, and analyzed. Statistics teaches you how to carry out all these tasks. Having completed the step 1, step 2 in a statistical study involves decision making based on the insight into the data. Assess if the information is adequate, gather and analyze additional data if required, make informed decisions, assess the risk on making wrong decisions. Statistics provides the tools and process to carry out these steps. Step 3 in statistical study involves reviewing the decisions and evaluating the judgments. Are the decisions made on university financial aid based on students' family income, social status, etc. are fair? Are there still deserving ones left out? Are the conditions on employment based on drug screening decided correctly? Aren't there errors? Is it acceptable to make offers to those under drug influence even if they are few in numbers? What is the tolerance? Statistics provides formal methods to evaluate the judgments. Variability. What is the significance of variability in a statistical study? What if every individual in an organization spend exactly the same amount of time on online shopping during office hours? What if everyone spends exactly the same amount of time on their cell phones and laptops in their vacation or travel? What if every child in a given population is bottle fed until they complete exactly second year of their age? What if every student's financial social status measured is exactly the same when evaluated for educational aid? There is no variability whatsoever in such data. Statistics will have no role to play if such were the circumstances. However, such circumstances are not realistic though. Variability, on the other hand, is always present in reality. Understanding the underlying variability forms the fundamental to statistics. Variability. Some illustrations. Distribution of heights in inches among the basketball team members in a tournament. Distribution of heights in inches among the gymnastics team members in a tournament. Heights of the members in the basketball team vary between 66 and 76 inches, whereas the heights of members in the gymnastic team vary between 60 and 74 inches. While the heights around 72 inches is a more common value, values around 66 or 76 inches are little rare values in the basketball team. While the heights around 66 inches is a more common value, values around 60 or 74 inches are a little rare values in the gymnastics team. Let's illustrate the variability and its significance in statistics with an example. Let's take the case of a lake in a locality whose water quality is periodically tested by the local administrative body. The body has tested quality of water for 200 consecutive days and recorded the average contamination values for each of those 200 days. The histogram depicts the frequency distribution of the values recorded. For example, the number of days the contamination recorded were between values 13 and 14 or over 40. 10 is the minimum value of average contamination recorded, and 19 is the maximum value of the average contamination recorded. The variability is between 10 and 19 amongst the average contamination values. An accident happens in a factory in the vicinity of the lake that leads to a chemical spill and some possible underground water contamination. As a consequence, the local body decides to examine the quality of the water in the lake to ascertain if the spill has any influence on the lake. Let's say the measured average value of the contamination is 14.5. Does it indicate an influence of the chemical spill? Conclusion will be mostly no. The reason is the value 14.5 is not a rare reading considering the variability displayed by the histogram. Let's say the measured average value of the contamination is 17.5 instead. Does that indicate an influence of the chemical spill? Conclusion will be perhaps yes. The reason is the value 17.5 is unusually a rare reading looking at the variability displayed by the histogram. Let's say the measured average value of the contamination is 20. Does that indicate an influence of the chemical spill? Conclusion will be a confident yes. The reason is the value 20 is a very rare reading given the variability of the contamination values. As one can see, the variability in the contamination levels recorded in the database play an important role in the decision making. Variability helps us understand the usual and the unusual values. Statistics provides the formal means to assess and make the decision with a certain level of confidence. The entire set of steps spanning across getting more insight to making decisions and judgments are not carried on the entire set of individuals or objects under the study. Instead, on a smaller subset, extracted out of the entire set in a prescribed manner. The entire collection of individuals or objects of which the statistical study is about is called the population, and a carefully selected subset of the population in a prescribed manner for the study is a sample. The steps involved in the statistical analysis process is broadly classified into two branches, namely descriptive statistics and inferential statistics. Descriptive statistics is a branch of statistics that details the methods for data exploration in terms of organizing, summarizing, and primarily getting a grasp and describing the variability in the data. Inferential statistics, on the other hand, involves formal methods that are deployed in arriving at the judgments. Generalizing the judgments made from the sample to the larger population to which the sample belongs to, and assessing the generalization of the judgments on the population. The prerequisite for step 1 is collection of relevant data. Quality of data collected starts with a very good understanding of the problem under study. The problem should then be translated into right set of questions for which the study should seek the appropriate answers. That leads to fixing what measurements have to be carried out and how to measure them. That in turn should lead to identifying what data, sources for the data, and how to collect that data. All these steps together in the prescribed sequence form the statistical data analysis process. Data, types, and visualizations. Having understood the role of statistics, the significance of variability, and the data analysis process at a top level, let's dive into the data and develop the preliminary understanding on the types of the data that we deal with in statistical studies and basic visualization means to explore the data. There could be one or more characteristics of the population that could be of interest in a given study, like age, gender, height, weight, etc. in a population. Each one of these characteristics is a variable whose value is different for each individual or object. And data is an observed value or values of one or more of the variables of interest. Dataset that consists of observations on a single characteristic variable or an attribute is called a univariate dataset. If observations were on two or more characteristics, variables, or attributes, then it is called a bivariate or a multivariate dataset respectively. The observations on a variable in a dataset can be categorical. For example, means of transport as in bike, public transport, car, by foot, etc. Or the observations on a variable in a dataset can be a numeral. For example, height in inches as in 65, 72, 68, etc. Example of a bivariate dataset. Two variables in the dataset, namely are studied and test scores for each student. Both are numeral values and hence is a numerical bivariate dataset. Example of a multivariate dataset. Three variables in the dataset: household size, annual income, and number of pets for each household. All three are numeral values and hence is a numerical multivariate dataset. A numerical variable can either hold a discrete data value or a continuous data value. All possible values for a discrete numerical variable is represented by a collection of isolated points on a number line, and all possible values for a continuous numerical variable is represented by an interval on the number line. In general, discrete data results out of counting. For example, like number of safety violations per airline recorded in a year, number of telephone calls to a drug abuse hotline every day, etc. While continuous data are a result of measurements. For example, like the amount the airline pays per year as a fine towards violations, GDP per capita per country, etc. Data visualizations. Introduction to statistics does not conclude without a preliminary exposure to some of the very basic visualizations of the data. Visualization of the data provides an effective means to summarize and comprehend the data. Graphs and tables form the very basic visualization mechanisms. Categorical data is often represented in a table format called as the frequency table, wherein the possible categories are listed in one column and the number of times each category occurs, which is also called as frequency, in the adjacent column. For example, watch TV as a leisure activity is observed among 84 people in a group when surveyed at a given point in time. And similarly, 8 people were observed making phone calls to their friends during that time. Along with frequency or instead of frequency, a relative frequency column as well could be used, where the relative frequency is defined as relative frequency equals frequency divided by number of observations in the data set. For example, relative frequency for leisure activity read equals 26 divided by the total 200, which equals 13%. Relative frequency for category is nothing but the fraction or proportion of observations resulting in that category. Bar charts are the graphical visualizations of the frequency table for categorical variables. Bar charts either display the frequency or the relative frequency. Horizontal line represent the category labels and the vertical line represent the frequency or relative frequency. Bar charts help visualize the more and less frequently occurring categories effectively. Dot plots, on the other hand, help visualize the numerical data when the data set is especially small. Each observation is represented by a dot above the location corresponding to its value on a horizontal measurement scale. When a value occurs more than once, there is a dot for each occurrence, and these dots are stacked vertically. Dot plots help understand the typical values in the data set, the spread of the values, outliers, and the general pattern of the values. As discussed, the frequency tables, bar charts, and dot plots are only a few among the many means for visualizing and summarizing data. There are a lot more visualizations and graphs possible to explore various forms of data, and they should be dealt in an exclusive video on data explorations. That brings us to the end of the session on the introductory video on statistics, role and process. Please leave your comments if any, and I'll revert back with my response ASAP. See you with the next video on the playlist of essential statistics for data science soon. Bye till then.